Thanks for tuning in for another episode of Math with Mullins. Today we're looking at volume of prisms and cylinders, so we'll be able to find the volume of a prism and a cylinder, check the formula for density, and also be able to apply that. First thing we want to know is what is the volume of a prism, and the prism can be found by finding the area of the base times the height. So the only difference here is we're given this capitalized B, and B, big B stands for area of the base. So we're going to try that here. So we're going to do area of the base first times the height. The area of the base here is a 3 by 4 triangle. So we would do 3 times 4 divided by 2, and then times that by the height, which is 2. Okay? Now, a lot of people, what they do is they just make sure they're using the lengths for the base and the height of the triangle. So they'll just do 3 times 4 times 2, and then stay with the dividing by 2 at the end. Either way you do that, that is fine. You should get 12 cubic centimeters. For this next one, notice we have a trapezoid. So you've got to remember the formula for a trapezoid. It is 1/2 the height and then times the bases added together. So we would take 1/2 of the height. The height of the trapezoid is 3. Add the bases together, which is 14 and 6. And then times that by the height, which is 5. Okay? For this one, I know 3 times 14 plus 6, that's going to be 20. So that'll be half of 60 times 5, or 30 times 5, and I'm going to get 150 cubic centimeters. Okay? Volume of a cylinder can be found the same way. It's area of the base times height, but this time your base is a circle. So for letter A, we would start with area of the base, which is our circle, times by the height. So that is pi times 9 squared times 6, and we should get about 1,526.04 cubic feet. And then for this one over here, letter B, pi times area of the base, 4 squared, times the height, which is 7. I'm going to get about 351.68 cubic centimeters. Okay? These two, let's try them on your own. Now that you've seen some examples, go ahead and click pause here, find the volume of both prisms, which are triangular prism and cylinder, and then play it to see what your answer is. All right, for this one, we just did 9 by 5, because that's your triangle, times the height, which is 8, and then divide everything by 2. We get 180 cubic meters. And then over here, we did pi times 8 squared for your circle, and then times by the height of 14. We get 2,813.44 cubic feet. Okay. Next up, we're going to talk about density. Density is the amount of matter that an object has in a given unit of volume. It'll be telling us how much density a object has, and we'll be essentially looking for the mass. There are a few other things you can read here. You can pause the video here if you want to read more, but essentially we need to focus on how to find density, which is mass over volume. Okay? So this diagram shows the dimensions of a standard gold bar at Fort Knox. So gold has a density of 19.3 grams per cubic meter. So remember, density is equal to mass over volume. So I'm going to write, I remember this as saying DMV. Okay? Density equals mass over volume. Because density of the gold cube is 19.3 grams per cubic centimeter, but you notice that these are all in inches, the first thing we got to do is change inches to centimeters. So we're going to multiply these by 2.54. Okay, so as we do that, this 7 inches is approximately 17.78 centimeters. This 3.65 is about 9.2075 centimeters. And then this 1.75 is about 4.445 centimeters. Okay, so those are the ones that we want to focus on going forward, since your density is measured in cubic centimeters. The first thing I need to do is find the volume. So I'm going to multiply my 7.78 centimeters times my 9.2075, that's area of the base, and then times the height, 4.445. That volume rounded is going to be about 727.69 cubic centimeters. Now I'm going to take that and plug it into my formula with density to find the mass. So my density is 19.3 cubic centimeters. Don't know my mass, but I do know my volume is 727.69, which means I'm just multiplying my density and my volume to find my mass. So the mass is approximately 14,044 grams. Okay, this next one is very similar. If you want to pause this here and try this one on your own, remember you're doing DMV. Oops. So go ahead and try that, and when you're done, click play to check it. All right, again, all these are in inches. Your concrete density is measured in centimeters, so we're going to multiply everything by 2.54 here per the conversion chart that you get. So you should get 60.96 for centimeters for my radius, and then for that height, you should get about 81.28 centimeters. Okay, so to find my volume, I'm doing pi times the radius squared, so 60.96 squared, and then times my height, which is 81.28 centimeters. That volume is a large number, 948,425 and 58 hundredths. Okay, now let's take that density. 2.3 is my density, finding my mass over 948,425.58. We're essentially multiplying your density and your volume to find your mass. So mass is approximately, to the nearest gram, 2,181,370. We'll go ahead and round that to 9 grams. Okay. All right, next few are just recapping volume and finding missing pieces of it. This is a rectangular chest. We have the length to be 6, the width to be 4, and the volume is 72 cubic feet, so what should the height be? We know that we can find volume if we take the area of the base, which is 6 times 4, and multiply it by the height. Height is unknown, so that means my base is 24 square feet, so all I gotta do is divide both sides by 24. I'm gonna get height as 3 feet. Okay? Excuse me. You're building a 6-foot tall dresser. You want the volume to be 36 cubic feet. What should the area of the base be? So we know area of the base is unknown here, but we know that the height is 6. So big B times 6. What is going on with my pen here? Is equal to 36. So that means the area of the base has to be 6. So some possible lengths and widths, you could be 3 feet by 2 feet maybe. Okay. Next up, similar solids. This one's an important one to make sure you understand. Similar solids can be found if you notice that their heights or radius are having equal ratios. That ratio for the corresponding linear measures of two similar solids is called that scale factor. So if two similar solids have the same scale factor of K, then the ratio of their volumes is equal to K to the third. So we have an example here, cylinder A to cylinder B. We notice that they have a scale factor. So if I look at from B to A, my scale factor, I'm increasing by 2. So K is equal to 2. So that means if I know the volume of B over the volume of A, it should be equal to K cubed, or 2 cubed. I don't know the volume of B, but I do know the volume of A, and the volume of A is 45 pi, and that's equal to 8. So in order to find my answer, I'd be multiplying 45 times 8, and I'm going to keep it in terms of pi, so the volume of B is 360 pi centimeters cubed. So we're going to keep pi, or keep in terms of pi, okay? So see if you can try this one here. How does prism C go to prism D? Is there a scale factor? And then what could we do going forward? Okay. So Prism C and Prism D, if you think about this, they have increased by 4 times the amount. So I'm going to use the scale factor of 3 to 12. So that means I'm starting with Prism D and going to Prism C. So my scale factor is 1/4. Okay, so that means the volume of D over the volume of C, which is 1536, is equal to 1/4 cubed. If you went backwards, if you did C to D, that's fine. It would just be 1536 over volume of D is equal to 4 cubed. Okay, to solve this, I'm going to go ahead and multiply both sides by 1536, so the volume of D can be found if I take the 1/4 cubed, which is 1/64, and times that by 1536. So the volume of D is equal to 24 cubic meters. Okay. One last one, find the volume of the concrete block. This one is just where you're finding the big block minus the 2 small. So your big block can be found by doing 1.31 times 0.66 times another 0.66, which gives you 0.5706, and then your 2 small, 2 times 0.33 times 0.39 times that 0.66 height again, you're going to get 0.1699, and then you're just subtracting because those are blocks taken out. So you should get about 0.40 rounded to the nearest hundredth. Okay, that's all we had time for today. Thanks so much for tuning in, Geometry. Hope this helped you find the volume of prisms and cylinders. Tune back in next time when we talk a little bit more about some more 3D shapes. Have a great day.